Hello students. So in the last lecture we had seen about the different states of matter, and we spoke about the state of matter solid, we spoke about liquids, we saw the properties of the particles of solids and the properties of particles of a liquid, right? Now we'll try to understand the third state of matter, that is gas or the gaseous state, right? So now in comparison with solids and liquids, let's look at the particles of a gas. Now students, in a gas, as I had told you earlier, the distance or the space between adjacent particles in a gas are very large, right? There are large spaces between the different particles. You can call them, there is a lot of space between the atoms and molecules of a gas, right? That is why you will find that these particles, they have a less force of attraction between each other because they are far away from each other. So the force of attraction between adjacent particles in a gas is very less, and that is why the particles of a gas, they move very freely and they have a random motion. Random motion means moving in different directions with different speeds, and they spread over a large area. So the particles of a gas, the force of attraction being very less between the particles of a gas, you'll find that there is a lot of random motion of the particles of the gas, right? So much so that they move freely with high speeds. Sometimes while moving they collide with one another, right? They dash against each other, plus they dash against the walls of the container in which they are kept. Whether you keep it in a gas jar, or you keep it in a cylinder, or gas is enclosed in a room, or maybe gas is filled in a balloon, the particles of the gas, they exert a pressure on the walls of the container in which they are kept. That is because the particles are being far away from each other. They move in different directions randomly and dash against each other as well as the walls of the container in which they are kept, right? So you will find that there is a lot of pressure on, you blow air into a balloon, because of the particles of the air exerting pressure on the walls of the balloon, you'll find the balloon taking a different shape. That's because the particles are exerting pressure on the walls of the balloon and they are making the balloon change its shape because of that pressure. Now what is the pressure exerted? The force exerted by the particles of gas on a unit area of a container in which it is put is called as pressure exerted. Pressure is the force acting per unit area, right? So the pressure exerted by particles of a gas on a unit, the force exerted by the particles of a gas on a unit area is called the pressure exerted by the gas. Now you know the particles of gas of one type of gas can diffuse with the particles of the other type of gas very easily. That is because of the large spaces between the particles of gas. So let's say you are sitting in your hall busy, maybe playing a game on your mobile, and suddenly you get or you know what type of food is being cooked in the kitchen by your mother, right? That is, you are sitting, even without going into the kitchen, you know what is being cooked. That is because the particles from the aroma or the fragrance of food, they mix with the air and intermingle with the air. That means that the particles of the aroma of the food, the fragrance of the food, they mix with the particles of the air and are carried very fast over a large distance into the room which you are sitting, and therefore you can easily guess the food that is being cooked in your kitchen. I gave you the other day the example of the incense stick, agarbatti, right? Being lit in one corner of the room, you can get its fragrance far in another corner of the room. That is because the particles of the gas, they spread very fast. Now, because these particles are far away from each other, therefore you will see that gas has a high compressibility. Compressibility means you can bring the particles of gas close to each other by applying pressure. So you can reduce the volume of a gas. Right? You are seeing the cooking gas in your house. A huge volume of the liquefied gas or the gas, a huge volume of the cooking gas is compressed under pressure into a small volume and filled in a cylinder, right? So you'll find the cylinder heavy because when you reduce the volume, the density increases. I will talk to you about density now. Gases, as I told you, are highly compressible because the distance between their particles are very large. There is a lot of space between the adjacent particles of a gas. So by applying pressure, you can bring these particles close to each other and reduce the volume of the gas, right? So this, you'll also find oxygen cylinders used in hospitals. You must have seen a person taking a huge cylinder of oxygen into a hospital. So a huge volume of oxygen is compressed into that small narrow cylinder, right? Today you find auto rickshaws also using what is called as CNG, that is compressed natural gas. Now this compressed natural gas is a huge volume of natural gas that is packed into a small cylinder that is fitted into the vehicles like auto rickshaws, and it is possible to compress a huge volume because the particles of gas have a big space between them, and you can reduce the volume by applying pressure and bringing the particles of the gas closer to each other. So you have understood the properties of gas. You know now, because the particles are free to move in different directions and they have high kinetic energy moving in different directions, this gas does not have a definite shape. It takes the shape of the container in which it is kept. So students, we will just take up an activity 1.11 which is there in your textbook. The activity is basically to bring up across the point to you, or to make you understand the difference in compressibility of the different states of matter, right? That means, in other words, you will learn which state of matter is easy to compress and which is not, right? So now in that activity, they have asked you to take 3 syringes. You know what are syringes, right? Syringes are the ones that doctors use to inject you when you are not well, right? So you take 3 syringes. From all the 3 syringes, you remove the top and just put a rubber stopper. Put a rubber stopper on the 3 syringes, right? Now, in one of the syringe, you just keep it aside. That means there will be only air in that syringe, right? Then in another syringe, you can fill water, and in a third syringe, you can put pieces of chalk, right? Now, just remove the piston. You know, the piston is the pump with which you press. When you play Holi, you splash water on your friends with the help of the pump that you push. The part of the pump that you push is called the piston. So take out the piston and just put a little Vaseline on it to make it smooth when it is pushed in the syringe, right? So now remove the piston, put Vaseline, then put the pistons back in their respective syringes. Now you try pushing all the 3 syringes. First, push the syringe in which there is nothing, there's only air. Push it, right? When you push it, you'll find that it goes down very easily. Then take the syringe in which there is water and try pushing it down, right? You will find that there is a slight difficulty in pressing it, but you will be able to do it to a less extent. Then try pushing the syringe in which there are pieces of chalk. You will find that it's going to be very difficult to push the piston in which the chalk pieces are kept. So it is understood from this activity that it is easier to compress gases, right, because the particles of gases are far away, so it's easy to compress the air in the first syringe than to compress either the water or the chalk pieces in the other syringe, right? That is why it explains that the particles of gases being far away, it is very easy for one gas to diffuse into the other gases. For that matter, liquids and gases can diffuse in each other also because of the space. So it is much easier for solids to diffuse into liquids and still more easier to diffuse into gases. So both solids and liquids can very easily diffuse into gases. You learn how a solid directly diffuses into a gas by the process of sublimation. You know the naphthalene balls kept in your house, they directly, or the bathroom fresheners kept in your house, they directly get converted from the solid state into the gaseous state, right? So that's an example of sublimation, where the solid particles directly diffuse or mix with the particles of air because of the large spaces between the particles of air, right? So we will take up the topic on density right now. So students, let me talk to you about density right now. The ratio of the mass of a substance to its volume is what we call as density. That means density is equal to mass divided by volume, right? So you will see how density increases or decreases if the volume increases or decreases. We'll just have a look at that explanation, right? But when you compare solids, liquids and gases, you will find that density of solids are comparatively greater than the density of liquids, and the density of liquids is greater than the density of gas. So if we compare the three states of matter, the density of solids are maximum, followed by the density of gas, density of liquid, which is less, and the density of gas among all the three states of matter is the least, because the mass of gas is spread over a large volume, right? The volume of gases are normally large. So students, let's define density. Density is defined as the ratio of the mass of a substance to its volume. Density can be given as mass upon volume, right? So from this expression you can see, if the mass remains constant and if the volume increases, the density value will decrease, right? On the other hand, if the volume decreases, then density increases. That means the density is inversely proportional to the volume. Volume कम होगा तो density बढ़ेगा, volume बढ़ जाएगा तो density घटेगा. That is the meaning of inversely proportional, right? So I told you that the density of solids is maximum, the density of gas is the least. This is all related to the distance between the particles of these different states of matter. So students, we have now completed our discussion on the states of matter. I hope your concept on the characteristics of the particles of different states of matter are clear to you, right? In case of any doubt, you can definitely get back and we will clarify the doubts. Now, in the next session, we will be taking up the topic on the change in the state of matter. We will be talking about how matter gets transformed from one state to the other and what is the effect of temperature and pressure on the states of matter. How do they result in a change in the state of matter? So till then, students, take care, stay safe and be happy, study regularly, right? So thank you students and bye to all of you.